Our goal for today, there's two things that we want to talk about. One of them is checking solutions, and that's really the main goal. So you guys are going to be solving a bunch of problems today, just to sort of practice the three methods that we've talked about so far. But back in first semester, I showed you all how to check your answers when you were solving an equation. Do you guys remember that? You remember how to do that? Some of you did this on your tests. And it always made me really happy when I was looking at somebody's tests and I saw that down at the bottom of the problem they had taken the time to check whether their answer was correct or not. So some of you know how to do this already, but for those who don't remember, I want to show you this. So imagine this was a test problem, okay? Imagine I gave you a problem like this on the test, and you did all the work and you got an answer of x equals -5. Now, I don't want you to go and solve this. I just want you to check and tell me yes or no, is -5 the correct solution to that equation? Do you remember how you would check that? What would you do? Yeah, we would put -5 in for all of the x's in that equation, and we would check to see if it worked. So let's do that. Can you guys please copy down this equation, but leave all the x's out? 4x minus 16 equals -6 plus 2x. Leave all the x's out. And in place of those x's, put -5. That's what we think the answer is. That's what we think our solution is. And I just want you to simplify that. Make it so that it's just a single number over here. Now, if you've got a calculator out on your desk, you could just type this whole thing into your calculator and hit enter and turn it into a number. You could type 4 times -5 minus 16 into your calculator. I'm going to work it out by hand, but if you could go ahead and type it in, and you can check and make sure I did it right. Just type in 4 times -5 minus 16. I'm going to work it out by hand, and we'll see if we agree. I think it's going to be -36. You check me and see if you agree with that. 4 times -5 minus 16. That's what you're getting in your calculator? Perfect. Okay. And if you type in this side, -6 plus 2 times -5, I think you're going to get -16 on that side. Is that what you got? So I put in my solution. I think the -5 is a solution. And I put it in and I get this. -36 equals 16, or -16. What does that tell me? Is my solution correct? Is -5 a solution? No, because why? Because that's not true. -36 is not equal to -16. That's false. So we have a sad face. What that means is that x equals -5 is not a solution. Now, oftentimes when we make mistakes and when we're solving, a lot of times it's positive versus negative, right? So what I'm going to ask you to do is, with the same equation, and you're going to do this one on your own, follow the same steps, take that same equation, but could you check x equals +5 this time? So do the same thing we did just a moment ago here. Just put a +5 in place of the x instead of a -5. Go ahead and do that on your own. So write down the equation again. Leave a space for your x's. And this time put a +5 in place of the x's. And use your calculator or use your mental math skills, whatever, and get me a number on both sides. Are you getting 4 on both sides? Yeah. What does that tell us? Is 4 equal to 4? Yeah. That's true. Is that good? Yeah. It is. That makes us happy. If we get something that's true, that means that it is a solution. So x equals 5 is a solution. Do you guys remember practicing this a little bit in the first semester? And remember how every time we had a test day, I said, hey, guys, when you're solving an equation, you know a way to check your answer. If you've got 10 minutes left at the end of the period when you're taking a test, go back and check your answers. It's not hard to do. It doesn't take a lot of time. All right. Okay. Now, when we're checking a solution that looks like this, it gets a little bit trickier because -3, 8, that has an x and a y in it. So this time when I check, I'm going to need to leave a space for the y and for the x. So copy that equation down, but leave out the x's and the y's this time. And we're going to plug in -3 and 8, but be very careful that you get them in the right spots. Is -3 the x or the y? X always comes first. In the solution, x always comes first. Now, x was here, so the -3 should go after the 6. And the 8 is the y, so the 8 should go out here. It's really easy to flip those around if you're not careful. This one's going to go pretty quick. Let's see if this works out and makes us happy. That's already a single number. -6 times -3 is 18. 18 minus 10 is 8. What's that tell us? It is a solution. -3, 8 is a solution to that equation. All right, same equation, different solution. Do you think it's going to be a solution also? What do you think? Test it for me. Could you guys test 1, -16 in the same equation? So again, make sure you leave out your x and your y and be very careful about getting the right number in the right spot. I am hopeful that you're finding that that one is also a solution. Is that what you got? Yep. So we've got 2 solutions to this system of equations. How many do you think? It's not a system, it's a single equation. How many solutions do you think there are going to be for this thing? Do you think we could find more? Maybe. How many more? Infinite? That's like the most more. Yeah, and it's right. There are an infinite number of solutions to this. If you have an equation with x's and y's and it's just a single equation, there are an infinite number of solutions for it. Now, we're going to actually be dealing with systems, so there are going to be 2 equations, and there will not be an infinite number. So when we're dealing with a system of equations, what we got to find is a solution that make both equations true. All right, we're going to do example 5 and example 6, and then we're going to be done for the day, and we'll start on our assignment. So this is kind of that main thing. Don't lose me here. Don't lose me now. This is the most important part of what we're doing today. Let's say it's 2.5 weeks from now, and you're taking test 1. Okay, worth a whole bunch of points. You want to do well on it. And I put this problem on here, and you get this answer. Sometime, something like that, a couple weeks from now. Let's say you get this as your answer, and you've got 10 minutes left at the end of class, and you want to check and see, is it the right answer, or do I need to go back and find a mistake? Can I get you to pick your head off your desk, please? Thank you. So how are you going to do that? Just the same way we did before, but we got to check it in both equations. So do me a favor, right here, rewrite both equations. I'm going to put mine right next to each other. Leave out your x's and y's. So y equals 4x minus 15. There's my first equation. And I'm writing small enough that I can fit the second one right next to it. Y equals 2x minus 7. Those are my two equations. And I want to check and see if this solution is the correct one for that. So I need to plug 3 and negative 3 in. Now keep in mind, the x is 3, so 3 should go here and here. Those are my x's. And the y is negative 3, so that's going to go here and here. That was where my y's went. And then I just need to check. Now, if both of these come out true, then my answer is correct. So fingers crossed. Let's see if they both come out true. First one worked. All right, fingers crossed. Does the second one work also? Wah, wah, wah. Second one did not work. What does that mean? Yeah, my answer is wrong. It's not the solution. It's not the solution. Now, does that mean that maybe the 3 is right, but the negative 3 is wrong? Not necessarily. They could both be wrong. Or maybe one of them's right, but there's definitely a mistake someplace. So if it's test day, and I just spent 30 seconds checking, I now still have 9.5 minutes to go back and find my mistake and fix it. Okay, but what I know for sure is that 3 comma negative 3 is not a solution. Could I get you guys to check this system here? You're going to put 4 and 1 in. Go ahead and start by rewriting both of your equations, but leave your x's and your y's out. And then test by plugging 4 and 1 in for x and y, and see, hopefully this time both of them will be true. This will be our last one for today. While you guys are working on that, I'm going to pass out your assignments. All right, my students will sometimes complain when I say you have to check your solutions, just so I can show you how long it actually takes. I'm going to do this like at real speed. So if I were doing a problem, if I were making the answer key, this is how long it would take me to check this. All right, first equation, second equation. All right, my x's and y's, x and y, x and y. 4 minus 4 is 0. Oh, it doesn't work. I got a mistake. I already know that it's not going to work. I got to check this one very quickly. This is 8, that's 6, 14 equals 16. No, neither of them work in that one. So there's definitely something wrong if I think 4 comma 1 is my solution. I need to go back and find my mistake. Okay, so it does not take a long time to check. I am going to ask you guys, actually I'm going to insist that you check answers for some of the problems on today's assignment. So before I cut you loose and allow you to work with some buddies on the assignment, I'm going to give you some specific instructions on number 1. I need you to check. Please write down that I need you to check. Tomorrow, or Thursday rather, when I check your assignment, if I don't see your work for checking number 1, you will not get credit for that problem. Okay? Flip over on the back side. You got 6 problems on this side. I need you to check 3 of these problems. Now, I would love to see everybody check all 6 of them, but it's not very realistic for me to ask you to check every single problem on every single assignment, okay? Especially because I show you the answers, and I will show you the answers for assignment 4 here in a moment. But on a test, I want you to be checking. If you've got time, you should be checking. Okay, on a test, you would not check while you were doing the problems. You would wait until you finished everything on the test, then you would go back and check your work if you had extra time. We're going to practice that on our assignments. You will be checking 4 of your problems, and if it's not right, I expect you to find your mistake and fix it. Okay, so I will be grading somewhat for accuracy on this assignment when we check it on Thursday. A couple other quick things. When you get to number 6, I'm actually going to ask you to pause on that problem because we're going to go over number 6 in the last 10 minutes of class. There's something special about that one. So skip it for right now. You're going to do it, so don't cross it out, but skip it for right now. Also, I would like to help you start problem number 2. So we're going to start problem number 2 together. We did not go over an example at the beginning of class of equal values problems with fractions. So I just want to remind you how this works. I know a couple of you weren't here when we did this, and it's been a while. So let me show you, let me get you started just on the first 2 steps. So this is an equal values problem. It says that in the instructions. So we're going to stick those 2 sides of the equation together. Everybody should be writing this down right now. This is going to be one of your problems. Are you with me? Get this down. We got negative 5 over 3x minus 1 equals negative 1 over 3x plus 3. And we can solve equations with fractions if we want to deal with the fractions, or we can get rid of the fractions. I'm not afraid of fractions, but if I can avoid them, I will. So, does anybody remember how we do this? The trick is to multiply everything in the equation. And what would I multiply everything in this equation by to get rid of all my fractions? Multiply it by 3. That's my denominator here, right? So I'm going to multiply everything times 3. Because when I have multiplication by 3 and division by 3, like there, they cancel. Multiply by 3, divide by 3, those cancel. Now these other 3's don't cancel because there's no division for me to cancel them with. So after I've done that, my equation doesn't have any more fractions. It's now just negative 5x minus 3 times 1 is 3. This is a negative 1x, and 3 times 3 is 9. And then that's a much easier problem to solve because we don't have any fractions to deal with. All right, and I'll leave it to you from there. Again, we'll come back and do number 6 together. One last thing before we wrap up, flip over on the back. This is the first time I've given you an assignment where you have to choose between 2 different methods. Really quickly, look at problem number 4 and tell me, does this look more like a substitution problem or an equal values problem to you? This is an equal values problem. And what do you notice about this that makes you think equal values? They can both have fractions, but that's a good guess. They both have a y equals. Both equations have a y equals, right? Y equals and y equals. When you've got two equations with y equals, that's equal values. What's number 5? Is that equal values or is that substitution? Number 5 is also equal values. What about skip 6 for right now. What about number 7? Is that equal values? This only has one equation that says y equals. This is a substitution problem. Okay? Do you guys feel confident that you can tell the difference between an equal values problem and a substitution problem? Get my attention if you need any help with that. All right, guys, let's get to work and be productive. I'll get your attention about 5 or 10 minutes before the end of class, and we'll talk about number 6. Let me unfreeze my screen. Number 6 on the back. Please pay attention because this is part of our lesson. I cut this out because I wanted to just do it as quickly as possible and get you guys working today. But take this opportunity to talk about the one last thing that we didn't get to today. And in the process, we will also finish up one problem from your assignment. So follow along with me on number 6. First of all, is this an equal values or a substitution problem? I only see one y equals, so that means substitution. So I am going to rewrite the top equation, 9x minus 3y, but I'm leaving the y out, equals -3. You guys following along with me, please? This is number 6 on your assignment. I left out my y because what am I going to replace? What am I going to substitute in place of that y? You got it. We're going to put 3x plus 5 in place of that y because that's what y is equal to. Now, something weird is about to happen, so prepare yourselves. Let's distribute this -3 here. So the 9x stays. What's -3 times 3x? It's negative for sure. -9x, thank you. And then -3 times +5 is -15. Here it comes. Are you ready for the weirdness? What is going to happen to this positive 9x and this -9x when I combine them together? You get 0. 9 minus 9 is 0 x's. In other words, they disappear. These two things cancel each other out, and then all I have left is -15 equals -3. Now this happened a few times in the first semester. We had an equation, we did all the steps right, and we ended up with something that had no more x's in there. There are 2 possible answers that we're going to write down at this point. Okay, so one of them is no solution, and the other one is infinite solutions. Which one is this? Is this no solution or is this infinite solutions? It depends on whether this is true or false. Is it true that -15 is equal to -3? No, that is false. And if it's false, we automatically write no solution and we're finished. Now, if it had come up -15 equals -15, that's true, then we would write infinite solutions. But if it's a false answer like this, we write no solution and we are done. All right. We've just got a couple minutes left, so feel free to pack up if you like. Thank you guys for your work today.